Alright, good afternoon Year 11 Exercise Science students. We've got myself and Mr. Slater here. We're going to be running through our bone dissection. Hey Mr. Slater, why couldn't the skeleton go to the party?
Because he had nobody to go with.
Or no, actually because of COVID-19, the Australian government's putting restrictions upon social gatherings of about 2 or more people, so he's actually staying inside practicing good social distancing.
Thank you. Gentlemen, it's a pleasure to be with you today for our bone dissection. So our focus today is on looking at the skeleton and recapping. We have here a cow's femur to work with today. So we're going to explore this and the cow's femur. Mr. Cook?
Let's get into it. Alright, wonderful. Thanks gentlemen. So, just a bit of a recap. We've finished our previous units and we've obviously had our turn test. So we've covered the respiratory system, circulatory system, and we're moving on now to more of the human body and the structures. So we're going to be focusing on the skeletal system, the articular system, and the muscular system. Okay.
And we're going to incorporate all these systems together, so we're going to come back to that initial concept of what is a cell and incorporate and link that back now with the bone today and bone structure. So a reminder, if you could please go to your Canvas page and please access the subheading on bone dissection. That'll be essential and critical, and we'd ask that you follow that worksheet through with our video today. Reminder, our learning intentions are, we're really focusing on the structure function of the skeletal system today. We're going to focus on the external features of a bone, the internal features of a bone, and the functions of red and yellow bone marrow. So you have an opportunity to research, answer questions. We're going to provide some guidelines, some notes for you, some hopefully interesting facts that we can just work together on as we work through our topic for today.
And hopefully make it a little bit humorous.
So just, gentlemen, as a recap now, Mr. Cook will demonstrate the following. So you would have researched last week that the function of bone is primarily to assist with bone movement. And we know there are 206 bones in the skeleton, all of which provide sites for attachment. And when a muscle contracts, it moves the bones to which it's attached and initiates movement, as Mr. Cook's about to demonstrate with the ulna and femur. So, not quite the movement I was thinking of, but it's there. Thank you, Mr. Cook. The second point is on support and protection. So the key, and Sir's about to highlight the rib cage, is about protection. And we know that the rib cage is critical to provide protection to namely the lungs and the heart. Next, mineral storage sites. And Mr. Cook is just going to highlight our bone today. Our bone from a cow, which is a femur, and which has been cut in half, and this will have the mineral storage sites. We'll look at this more closely, and also critically is involved in the production of blood cells. So that's a key part of bone today, which we'll focus on.
Hey Mr. Slater, what did the femur say to the patella?
Not sure, sir. What?
I need you.
Thank you, thank you. Gentlemen, some of Mr. Cook's jokes today are just literally bone dry. If we could also stress this, bone is stronger than reinforced concrete. All your bones weigh no more than 9 kilograms, yet most can withstand up to a ton of compression. Also a feature of bone is that it's bulkier. So the bigger an animal, the larger the body mass. So you'll be comparing the femur, as Sir's about to point to, of a human skeleton with the femur of a cow, and that is only cut in half, and you'll see that the heavier animal is the more massive its bones must be to support its body weight.
Right gentlemen, now we're sitting down here with the cow's femur. So what we're going to get you to do, we're going to get you to pause the video for just a second, and we want you to draw the femur as it is, okay? Because you're going to come along on this magical journey with us as we label the different parts of the cow's femur and be able to identify the function of each component.
Okay, so everyone's got now a picture of the cow's femur in front of them. To identify key parts, you'll know now from your reading that the ends of the bone are referred to as the epiphysis. So each end at the end is referred to as an epiphysis. The centre shaft of the bone from here to here is referred to as the diaphysis. So a key part here, so we have epiphysis, diaphysis, and if I roll the bone over now to clarify, we have what's referred to as the growth plate. Importantly, this term is referred to as the epiphyseal plate. So literally, our bones will lengthen, they will increase in size, but they also increase in length. So picture yourself as a 2-year-old, 6-year-old, 8-year-old, and now a 16, 17-year-old, and you'll know that your bones have grown remarkably in this time. Okay, so the next part is we've gone to the epiphysis. The epiphyseal plate, the diaphysis, is key to highlight this section referred to as the articular cartilage. This marble-like, white, glossy, but if you were to run your finger over this, very slippery, fine, very viscous. You can nearly picture this as the oil in the engine of the car that reduces any friction or parts rubbing over each other. So cartilage, as we've just mentioned, is remarkable, it's extraordinary. It's many times smoother than glass, as Mr. Cook's demonstrating. It has a friction coefficient 5 times less than ice. So imagine playing ice hockey on a surface so smooth that the skaters went literally 16 times faster. And unlike ice, cartilage is not brittle. So it's one of the best technologies that exists on Earth, is literally right here inside of us. So the last point on cartilage is think wear and tear. I just alluded to engine in a car, and you'd know that every 10, 15,000 cars is generally time to replace the oil in a car. Well, if we can think now wear and tear, we don't have literally the capacity to replace, repair or replenish itself cartilage. So if you've got a pair of shoes, think about how durable your shoes are, and you'd know that you probably wear your shoes out, your sports shoes, and we've got to think that cartilage has got to be sustainable, and we want to reduce that wear and tear where we can, and age sometimes is against us on that matter. Thank you.
So as you can see here on our knee, as it's bending there, if you focus in on the light blue section there, as the knee moves, the light blue bit there, the cartilage is actually going to help protect on that wear and tear to prevent bones from just grinding against each other. Okay, so now we're going to be looking at the diaphysis of the bone. So we've known that through as forming as the compact part of the bone. So as you can see here, and then on our knee here, it is the compact part. So that is the tough, firm part of the bone, also known as the shaft.
And then we go to the spongy or canciolus. So you'll see 2 terms to describe this. This is matrix-like appearance. If you could think of a honeycomb chocolate, with the outer side being the chocolate and inside the centre is this honeycomb matrix-like appearance. You'll see here red blood cells coming through, and this is what we're going to distinguish between red bone marrow and yellow bone marrow.
Okay, now that we've actually spoken about the structure of the bone, let's marrow in on a few different facts surrounding the end and the middle part of the bone, or the epiphysis and the diaphysis.
Fantastic, sir. So at the ends of the bone now we have the red bone marrow, and as I just mentioned, is producing red blood cells. Mr. Cook's pointing to that. Also critical is it will produce white blood cells, platelets, and this red blood colour comes now, as you know, from hemoglobin contained in the red blood cells. So key part there, and we've discussed that as part of our circulatory system. So hopefully you can see the link together now, production of red blood cells, white blood cells, platelets, and where does this take place in the human body. So gentlemen, now sir's pointing to what is this is very solid and very hard. Now we're going to move into something that's totally different, is this cavity which is hollow. This is the yellow bone marrow that sir's teasing away at right now. It will produce fat cells, cartilage, bone, and it's yellow in colour, but you can see now it's more white in colour or opaque. So very soft is sir's going through, and we're going to dig this out now and come back to you with it completely empty. So some key terms now. So we've got here an adult cow, dead, deceased sadly, but the femur, we've got a picture that most of this would have been cartilage. So if you've been reading your notes, you'll know about a term called bone and ossification. So here the bone is becoming dense, it's becoming strong, and really the cartilage is being replaced totally by bone. Key to this is the feeding of this artery and vascular system reaching out and through to the bone. You'd note here, as we're researching now, this is a long bone. So if you understand that, if we went back to our skeleton, tib, fib, radius, ulna, anything else, sir? Humerus, as you've already alluded to. And just following the humerus, sir, have you got anything to add?
I've got a bone to pick with you, sir. What am I pointing at you with now?
A phalange. Many times it's mistaken as a short bone, but we know, sir, a phalange is, and we're not allowed to touch, is a long bone.
And finally, you'll see here, if we can flip the bone over, we'll see just underneath the myelin sheath there, we have what's called our periosteum. So the periosteum essentially provides a protective layer for our compact bone.
I invite you now to focus on what Mr. Cook is pointing at. So we're really going to just wrap up. We've looked at bone and we can go right back to our start about function of bone is about movement. So linked to bone is also tendon and ligaments, which are types of connective tissue. So tendon, as you know, connects muscle to bone. It's stretchy. And tendons are essentially basically extensions of muscles. So we've also got a situation where we've got ligaments, and ligaments connect bone to bone. Ligaments are a little bit more white, opaque in colour. Here's red, but if you look to where Mr. Cook's pointing now, you'll see some strong fibrous tissue, and that is really a perfect example, has been cut, of ligament. Let's go back to one of the key functions about movement of the skeletal system. So muscle, bone, tendon, ligament work together in splendid choreography. Nowhere is this better demonstrated than in your hand. Your hand contains 29 bones.
We have the carpals, our metacarpals, and our phalanges that all work together to perform our basic movements of the hand.
Assisting that is 17 muscles, 2 main arteries, 3 major nerves, 45 other nerves, and approximately 123 ligaments, all which coordinate every action with precision and delicacy.
Wonderful, so that brings us to the end of our bone lab dissection of the cow's femur. Thank you very much for watching along, gentlemen. To be honest, we hope you're having an blast with your online learning. Try and make it as enjoyable for you as possible. So thank you very much. Mr. Slater.
Thank you, sir.
Yes.
Thanks to our viewers.
Why aren't skeletons good liars?
I don't know, sir. Why aren't skeletons good liars?
Because you can see straight through them.